All right, guys, so we're going to go back and we're going to do the U.S. company example again, this time with factor analysis, just to look at what some of the differences are. One of the things I want you to do here and one of the things I want you to see is how this works and how we're going to use it to our advantage. We're just going to use a two-factor analysis, and the way this looks is I'm just reading in the data. I'm going to do a transformation on the U.S. company data set. I'm basically just going to take the log of everything. That could get rid of some of that variation we saw in the original example. And just to show you a different feel of this, I'm going to give the sector names, which is what this is. There's some sector names. You guys know what these mean already. I'm not too worried about that. But you're going to use them here in a second. We're going to print the correlation matrix just so you can see what it looks like. And I saved it just to be safe here. So here's what the correlation metrics look like. You can see assets has some correlation. Sales has high correlation with market value and employees. You then have market value with sales, and it has something with employees as well as cash flow. So, if you're looking around there, everything's above 0.5 in market value. If you're looking at profits, cash flow is a big indicator of that apparently. So as you go through this and as you look, what you're going to do is you're going to start trying to recreate this covariance matrix, okay? Now, the factor analysis piece, there's a function called factanow, stands for factor analysis. And what we're going to do, we're going to run on the scaled version of U.S. companies. Now, the U.S. companies data set, again, is what you saw above. I'm going to say the factor is 2, and there's a none rotation. This rotation is how do you estimate it? So this uses something, just a kind of a maximum likelihood approach. There's another one out there. The options give you a lot of different things you can do. You can play around with that a little bit with what you want. Really what it does is it changes things slightly. So here's what you get back. This is your psi. Okay, psi was the diagonal matrix, and it talks about the uniqueness. This is the psi associated with every variable: assets, sales, market value, profits. Basically what it's doing is it's telling you how well this matrix right here, or your factor, picks up the covariance of everything. You still see we're missing 0.638 on assets, sales 0.04, so it's good comparatively. Market value 0.34, profits, cash flow, employees, etc. So the entire idea here is we have this many coefficients basically to estimate P times K plus P, right? This is P times K. This right here is your loadings. This is your Q matrix. This is what you're looking for, okay? This is what you're looking for. Down here, this is your summary. So it's the sum of squares of loadings, the proportion of variance each, and the cumulative variance. So think of this just as your scree plot or something along those lines where you're looking for the percentage of variance accounted for. What percentage did you get out of this? So if I look at this, here's factor 1, here's factor 2. Again, what you can do is you can try and interpret what these things mean. What do you see from them? Notice cash flow got zeroed out here because basically says this isn't large enough to matter. Look at how you have all these positive coefficients. This weighting basically puts more weight on cash flow and profits, right? You could look at that as the average of cash flow and profits plus maybe some average of the rest of those. So it could be considered an overall average. Or you could say, hey, look, this is just the average of profits and cash flow. You come over here, you could say this is the average of sales and employees with some assets. If you come back up here and look, we saw sales and employees had this high correlation. We saw this profits and cash flow had this high correlation. So basically what this could be telling you is take the average of both. Or you could look at this as an overall average. Look at this as an overall average if you wanted to. It just depends on how you want to approach the problem and how you see things. Now, remember, these aren't, you have to take them as fact. What they do is they're starting to create some insight for you to say, man, okay, what I could do is I could use this summary statistic or I could use this summary statistic. If we just decide to use one factor in this model, out of this two-factor model, you'll see we get about 50% of the variation of the covariance matrix. 2, we're at 80%. What you could do is you could play around and look at 2 to 3. Now, there's some different things you're going to do. As you go, what you're going to see is you're going to see this disappear because you're not able to test anything anymore, okay? What we have is in factor analysis, we have the ability to test a hypothesis. The test of the hypothesis is that two factors are sufficient. The chi-square statistic is 13.6 on 4 degrees of freedom, and the p-value is 0.00871. Now I want you to take a look. The test of the hypothesis that the two factors are sufficient. You know from basic hypothesis testing, null hypotheses are have equal in them. Alternatives say not equal. Two factors are sufficient. What that means is this two-factor approximation with this value of psi approximates this covariance matrix. That's what it's trying to tell you here. So when we look at this p-value less than 0.5, or excuse me, 0.05, reject the null hypothesis. We're rejecting the hypothesis that two factors are sufficient. So what you do is you increase this to 3. If you trust this hypothesis test, one of the ways to approach this from a sheer data mining perspective is to look for an insight. What can you take away? Guys, the hypothesis test doesn't matter as much if you're going in and looking for insight. You're still at 80% of the variation with two factors. That's pretty good, right? Two factors. What you've done is you've said, okay, this is, if it's me, I can look at it as an average, but probably that's an average of market and cash flow. Or excuse me, of profits and cash flow. And what's this? Well, this is sales and employees. So factor 1 is average profit and cash flow. Factor 2 is sales and employees. So from there, what I'm going to do is I'm going to go in and I'm going to start looking a little bit more and saying, okay, those are my two summary statistics I can use. Everything else doesn't really seem to matter a whole lot here. Maybe if I added a third factor, it would help me approximate assets a little bit better though. So let's look and see what this did. Now, this uniqueness up here, that's your psi, right? So I created a diagonal matrix of psi. I took Q and called it my loadings. So I'm going to say my estimated covariance matrix is this thing right here. Now I want you to take a look at this, guys, because this is actually fairly important. This is the difference. What I've done is I've recreated my sigma hat. I call this sig hat. This is my estimated covariance matrix. And I want you to look at this. Now this is the reason that hypothesis test right here can be somewhat important, because it tells me my error term. This, if you go back and look, this would be the error term associated with your model, because you imposed a model. This is the model you imposed. So this is the covariance matrix, the leftover from the covariance. So you can see you've missed some things. You've missed the correlation between sales and assets. Of course, you're going to have this 1 on the diagonal because we know all correlation variables correlated with themselves equal to 1. We're worried about the off diagonals. Some are high, some are low. You're missing the relationship between assets and employees, I mean, almost entirely. Market value, it looks like everything's kind of low there except market value and employees you're missing. So when you're coming in here and you're looking at these things, by adding more factors, maybe what it does, it picks these up. But also what it's going to do is it's going to add more. At some point, you will lose this hypothesis test because you will not have enough degrees of freedom to test the hypothesis, which is fine. At that point, this stuff starts becoming principal components. So you can go in, look at principal components, and approach it from that direction. When I'm looking at this, though, what I'm seeing is I'm getting some insight into summary statistics that are possible to summarize all this information. Rather than looking at all of these, what I can do is I can go in and I can say, okay, it's just profits and cash flow. That's the first factor. Second factor is sales and employees. Okay, so let's go in and let's start using those type of ideas to summarize this rather than trying to use this, all 6 variables here. So what we've done is we've really said it's reduced to 2 dimensions. In this case, reduced to 2 dimensions. There's 2 summary statistics that matter, and those 2 summary statistics depend on 4 variables. The first one, profits and cash flow. The second one, sales and employees. So as you're approaching this, you can approach it from that. Or you can go in and you can find insights. This is where you want to go back and you want to start talking to SMEs and say, does this make sense? So what I do is I go back and I talk to finance guys. I know I've got a couple in the program. So when you go look, you say, okay, what's this actually mean to you? Does this make sense? Or you go back, for instance, I talk to one of the econ guys a lot because some of my research stems on this stuff. So when I'm analyzing data, guys, my research is I develop the actual methods that go into this stuff. I don't just sit around and analyze data. But to publish papers, I have to at least analyze one data set with a new method. So what I'll do is I'll go back and say, okay, does this make sense? Or what I'll do is I'll look at methods like this and go propose new methodology off of this. Now, you're going to start seeing some of that new methodology and that development in Module 3 and as we go across. Because the whole idea here is, could I create some sparsity? Or could I raise this loading up to where all these loadings are equal so they make sense so I can interpret as a direct average? Could I do some things in those estimations to help them make sense? So when we're approaching these problems and when we're looking at it from that perspective, this is what matters. This is how we're going, how do I want to say this? This is how we approach the problem, okay? So as we go through this and as you continue to hear it, I want you to try some things. So with this, go back and look at 3 factors. Take this, do the example in art, and then go back and look at the U.S. companies example. And talk to me about the differences. Talk to me about the insights you see. If I just go back right now and look at what this looked like from principal components, there's not a right or a wrong here. But what I'm able to do is I'm able to go back, and I did this off untransformed data, so you can look at the effect of transformation. You can look at the effect of what you want. Look at what we did here. We said this was a total average, right? We did this as a total average. It wasn't just, profits and cash flow. We had sales and market value and assets and employees and everything else in there. So when you're approaching things like this, you want to set it up for comparison. So what you should do is you should go in here to your U.S. company example, and you should either use it without the transformations or go back and do principal components with the transformations. Try some things. Look at what the changes are. These are the insights you can get from by just example after example with this stuff. So I know I promised you examples in this class, but a lot of this stuff you're going to have to go and try. That's the practice I want for you inside of this. That's the reason we've got shorter modules, is because I want you to go in and I want you to practice this, and I want you to start looking at the results and start thinking through how they change. You're not always going to have me sitting there to talk you through the examples. So now that you've seen an example of principal components and now you've seen an example of factor analysis, what I want you to do is I want you to put the two together and talk to me about what the differences are. Think through the problem. All right, guys, let me know if you need anything. Let me know if you have any questions.